transfer function of negative feedback. Negative feedback system. For a negative feedback, the error signal at point is for a negative feedback, error signal at point A is equals to RS කියන්නේ input නේ. එතකොට RS අඩු කිරීම HS CS. HS කියන්නේ feedback path එකේ තියෙන එක, CS කියන්නේ output. ඒ දෙක multiply කරලා අඩු වෙන එක තමයි වෙන්නේ negative feedback එක. ඉතින් මේකම තමයි. ඊට පස්සේ output එක මොකද්ද? Output is feedback loop forward path transfer function එකයි GS එකයි CS එකේ ගුණ වෙනවා. නෑ වැදුනා. CS කියන්නේ output නේ. output කියන්නේ CS සමානයි AS එක GS කෙන් ගුණ වෙලා. ඒකෙන් තමයි එන්නේ. හරිද? එතකොට AS වෙනකොට මම දානවා මේක RS HS CS කියන එක. ඒක multiply වෙන්න ඕනේ GS කෙන්. හරිද? ඊට පස්සේ CS සමානයි RS GS minus GS HS CS කියලා එනවා. මම CS තියෙන එක පැත්තට ගන්නවා නම් CS plus GS HS CS සමානයි RS GS කියලා එනවා. ඊට පස්සේ CS ගන්නවා 1 plus GS HS සමානයි RS GS. ඊට පස්සේ output එක ගන්න මම බෙදන්න ඕනේ CS එක RS කියන. එතකොට CS බෙදීම RS කියන එක එනවා මට GS බෙදීම එක දන GS HS කියන. එතකොට මේක තමයි මේ output එක. හරි, එතකොට question 1 ඉවරයි. ප්‍රශ්න පාඩුවකට කරන්න තියෙනවා. ඊළඟට මේකේ question නම් කරනවද? කවදාද කරලා වෙනම් කර. මේකේ ප්‍රශ්න කියලා තියෙනවද? any 4 නේ. attempt any 4 questions from 1 to 4 මේකේ 1 to 3 1 to are compulsory. You must answer any 3 of the questions for 3 to 7 මේ කියන්නේ you must කීයක් ලියන්න ඕනද එතකොට? question 1 2 3 1 2 are compulsory. You must also answer any 3 of the questions. මේකේ ප්‍රශ්න පහයි ප්‍රශ්න බොහොමක්. එතකොට දෙවෙනි එක තමයි initial and final value theorem. හරිද? එතකොට initial and final value theorem. මොකද කියන්නේ? Initial and final value theorems are important because they allow us to determine the system's starting and steady state responses in the time domain directly using transfer function in the Laplace domain, simplifying dynamic analysis. it states the initial value theorem and final value theorem. මොකක්ද කියලා නම් මම දන්නේ නැහැ. බලමු. අපි ඊට වඩා සරල කියලා දෙන්න කියලා කියමු. I don't know. Can you please explain this in very simple way, because I can't understand this, and since I am learning this for the first time, it is hard for me to understand what is going on. So can you please explain this in a very simple way so that someone who is learning this for the first time can understand it? These two theorems act as mathematical shortcuts. Normally, to find how a system behaves at the very beginning or after very long time, you would have to convert fs back into the time domain ft. Using inverse Laplace transform, which involves tedious partial fractions. These theorems allow you to skip that entirely and find the start and end values directly from fs. Initial value theorem. Okay, what does it does? Finds the value of the signal at the very beginning, t is equal to 0 plus, and then right after the input is applied, the formula is f0 plus limit t0 plus ft is equals to limit sfs. S goes to infinity sfs. How to use it? Multiply your function fs by s, then let s goes to infinity. Quick intuition. Time and frequency have an inverse relationship. If you want the behavior at extremely small time, t goes to 0, you look at this extreme large frequency, s goes to infinity. Oh, that's why we let this limit goes to infinity. All right. So this is initial value theorem. So final value theorem is what it is find the steady state value. The final value of the signal settled at the time at that time goes to infinity. The final value of the signal settles. The first thing is the signal at the very beginning is initial value theorem. The final value theorem simply it is the final signal value that just time goes by. We find it using f infinity, limit t goes to infinity ft is equals to limit s goes to 0 sfs. This previously it is limit s goes to infinity fs sfs. So how to use it? Multiply your function fs by s, then substitute s is equal to 0. Catch stability condition. And the theorem only works if system actually settles down to a constant value. Mathematically, all poles roots of the denominator of the SFS must have strictly negative real parts. Negative real parts. SFS must have strictly negative real parts lying in the open left half of the S-plane. If system constantly oscillate like a poor sine wave or a blow of infinity, blow up to infinity, the limit t goes to infinity ft does not exist, and applying fvt will give a mathematical full answer. Simple work example. This is a, so the final value initial value f 0 plus is initial value is limit t 0 plus goes to this is equal to sfs this. So we can convert this into s goes to infinity this, and then when I apply this I get the answer 0, and the final value so the initial value is 0, final value is the opposite, which means f infinity limit s goes to 0, s times 2 over s times s plus 3 equals to limit previously t goes to infinity, which means s goes to 0 this. So when s goes to 0 we get the 2 over 3. So without doing inverse Laplace transform, you instantly know what output. The output starts at 0 and eventually settle at 2 over 3. Yeah, that's it. So the initial value theorem is this. So I think I should study this. Other than this seems simple, but it is hard to understand. So I'm going to write this down in the paper. I don't know. I'm gonna write it in the simple language. If you're gonna give me the marks, you can give it. If you are not gonna give me marks, I don't know what to do. Yeah, I can, I can't study and memorize all the complex words. All right. So yeah, initial value theorem. Let's just write that down. Initial value theorem. Initial value theorem. Initial value theorem IVT එක ගන්න කොහොමද f0 plus සමානයි limit t goes to 0 plus ft සමානයි limit s goes to infinity sfs. Final value theorem අන්තිමට මම එකම තෝරගන්න තියෙන්නේ final value theorem f vt සමානයි f infinity සමාන limit t goes to infinity ft ඒක සමානයි limit s goes to 0 sfs. Alright. ඊට පස්සේ given the transfer function, use the initial and final value theorems to find the initial and final values. දෙවැනි එකේ initial and final values. Initial A is initial value theorem. Initial value theorem. දැන් මම initial value කියන්නේ limit t goes to 0 plus 1 ft is equals to limit s goes to infinity sfs. So I'm gonna substitute s here, which means 1 over s plus 2. So now what I can do is this is equals to s goes to infinity now. So 1 over s, no 1 1 plus 2 over s. So I get 1, I think. Yeah, I get 1 as the answer. And final value theorem is limit t goes to infinity ft, which means limit s goes to 0 sfs. Limit s goes to 0 s times 1 over s plus 2, which means this is equals to 0, I think. Let's check 1 and 0. Yeah, I'm correct. I'm happy. And then B, convert fs into its time domain function ft, and using the time domain function find the initial and final values. How to find it? Convert fs into I think Laplace inverse Laplace transformation, right? Using time domain function, taking inverse Laplace transform fs of fs, right? Yeah. Inverse Laplace transform of fs. Finding inverse Laplace transform of fs. So ft is equals to L inverse of 1 over s plus 2. So I get, normally they don't give a Laplace table, right, in the exam. I think I need to memorize those stuff too. The Laplace table too. Oh no, they are giving a Laplace table. What relief. So I have this s plus 2, which means it looks like this. So I get e to the power minus 2t, right? Yeah. So the answer should be e to the power minus 2t. Yeah, that's it. So the condition is t greater than or equals to 0. For t greater than or equals to 0. I don't know why they are putting that in there. So they are using the Laplace transform when t is greater than or equals to 0. I don't know. Maybe. Maybe. I don't know. Initial and final values, I don't know how to find them. Initial value is when f is 0. Final value is when f is infinity. So f0 is, then f0 is e to the power minus 2 0, which means e to the power 0, which means 1 initial value. And then final value is f infinity, which means e to the power minus 2 infinity, which means 1 over e to the power infinity, which means 0, right? I think I'm solving this in the wrong way. This can't be right in this way. We have to find a limit. Why is that? Let's ask from Gemini. What is the reason? When we try to find the initial values, we are not using a limit, but when we are finding final value, where the answer using is using a limit. So what's the reason for that? Is that the reason is like we are using infinity? Is that the reason? Yeah, the reason is that infinity is not a real number, so you cannot directly substitute it into an equation like a number. So for initial value, t is equal to 0 is well defined and you can substitute it directly, but you can't do it with infinity. So what you're gonna do is, um, so yeah, you can't substitute it like this. So what you're gonna do is limit t goes to infinity e to the power minus 2t, which means you get 0 in the end. So both Laplace domain computations. I don't know what is that. Let's just ask it from the Gemini tool. In here, they are saying both values are matching Laplace domain. What is that domain? I don't understand. And also, in previous example, when we converted the time domain, converted the Laplace uh, function into time domain, they are saying that t should be greater than or equal to 0. So what's the reason for that? I don't know the basic things, right? So that's why I'm struggling. So I'm just doing the past paper. So yeah, please tell me. What is the domain? The time domain versus Laplace domain. So the domain is simply the mathematical world or a perspective you use to view a single signal. The time domain T is the real world perspective. You see how a signal changes second by second over time. Second by second over time. Laplace domain, the frequency algebraic perspective, you transform the function using complex variable SFS on OS, so S plus 2. When the note says both results are matched, the Laplace domain computations, this means you have calculated the initial and final values in two different ways and both give the same exact answers. So that's the thing. Okay. That's the thing. That's the thing. So I got it. So why must t is greater than or equal to 0 in control systems and engineering? Unilateral Laplace transform. The standard Laplace transform is defined starting from 0. The standard Laplace transform is defined starting from 0. Okay. The integral does not look at the negative time. The casually real world physics, the physics same systems cannot react before you turn them on or give them an input. We define t is equals to 0 as the exact moment a switch is turned on or an input is applied. Before that t is less than 0, the signal is assumed to be 0. Would you like to talk? No, this is enough. I think that both results are matched to the Laplace domain means time domain and frequency domain, both answers are equal. That's the reason. Second order differential equation consider control system where yt represent the output and next t represent the input. The relationship between the input and output is governed by following second order linear differential equation. Okay. Show that the transfer function ys over xs, where is the Laplace transform of the output yt and xs is the Laplace transform of the input xt, is given by this. Stuff. I don't remember them. I don't know what to do.